Somewhere out there is a maker called Squid Ink who looked at a flock surveillance camera bolted to a streetlight and thought, that thing needs a sock. Tom's Hardware picked it up this week. It's a 3D printed slip-on cover, the flock sock. And the whole rig mounts on a broom handle, so you can cap a camera from the ground in about 2 seconds flat.
As pure design work, it's better than it has any right to be. A cover that self-aligns and seats over a camera housing, one-handed from 12 feet below, on the end of a wobbly pole, that is a legitimate mechanism problem. Most of us can't get a print to snap cleanly onto something sitting perfectly still on the bench in front of us.
And the reaction online is precisely the split you'd expect. Half the internet calling this maker a folk hero of privacy, the other half pointing out that covering equipment you don't own has a name, and the name is tampering. I'm not touching the legality with the broom handle in question, but as a piece of design provocation, it landed.
It sets the tone for the week. Honestly, almost nothing in this episode is about printers misbehaving. It's about printing colliding with the rest of the worldwide courts, militaries, patent offices, and the rest of the world scrambling to respond.
That's the week in one sentence, really. 3D printing stopped asking permission years ago, and now the institutions are drawing lines around it after the fact. The big story is a federal judge in Texas striking down the ATF's ghost gun rule, and we need to separate what that ruling says from what the headlines say it says. Then a suspiciously cheap 4-color printer from Creality, Bosch printing a V8 engine block, a 2-year-old Indian startup test-firing a printed cryogenic rocket engine, and IBM announcing it has discovered 2 extra dimensions.
The V8 block is the one I want to sink my teeth into. That's my old shop floor. Life colliding with the news cycle in the best possible way, and 5D printing is the one I've been rehearsing my sigh for since Tuesday.
Save the sigh, we'll earn it. Court first. So the biggest 3D printing story of the week happened in a courtroom, and I want to say up front, this is one where the headline and the underlying ruling are probably 2 different sizes. Tom's Hardware reported that a federal judge in Texas struck down the ATF rule classifying 80% receiver kits as firearms, calling the whole thing unconstitutional. And per that report, the reasoning ran on 2 rails: Fifth Amendment due process problems, plus what the judge apparently framed as a long American tradition of DIY gunsmithing. People have been making firearms at home since before there was an America to regulate them. That framing matters, because it's not a narrow procedural win. It's an argument about what home manufacturing has always been.
Quick backstory for anyone who wasn't following this fight. A few years ago, the ATF rewrote its definition so that a kit which could be readily converted into a working firearm counted as a firearm itself. Serial numbers, background checks, licensed dealers, the entire regulatory apparatus suddenly applied to a box of unfinished parts. And the motivation wasn't mysterious. These kits were being sold with no serial number and no paperwork, which is where the ghost gun name comes from. The rule was an attempt to close that gap by regulating the almost finished thing the way you regulate the finished thing. Whether the agency had the authority to redraw that line on its own is what ended up in front of this judge.
Okay, pause for anyone who hasn't gone down this particular rabbit hole. What is an 80% receiver? Because it's the load-bearing term in this entire fight, and it sounds like jargon designed to repel outsiders.
In U.S. law, one specific component is legally the firearm, the frame or receiver, the part everything else attaches to. Barrels, stocks, triggers, springs. Those are just parts. You can mail order them like lawnmower blades. And 80% receiver is that one regulated component left deliberately unfinished. A block that still needs drilling and milling before anything functions. Historically, unfinished meant unregulated. The ATF rule said if it's readily convertible, it counts anyway.
And readily convertible looks like where the due process argument bites, right? 2 words carrying an enormous amount of legal weight with no bright line underneath them.
That argument practically writes itself. Is 2 hours on a drill press readily, 20 minutes with a jig, when a rule can turn you into a felon depending on how a regulator feels about your tool bench. Courts get twitchy. Due process doctrine really doesn't like laws. You can't tell whether you're breaking. Now, a caveat on our end, we're working off one outlet's report of the ruling so far. The order itself will get picked apart properly as more coverage lands.
Here's where my old reporting instincts kick in, because I covered this beat for a while, and ghost gun stories nearly always mash 3 separate things into one scary phrase. 3D printed frames, 80% metal kits, and desktop CNC machines. Those are different technologies, different communities, different legal questions. The headline says 3D printed parts. But the case, as far as anyone can tell, is about the kit category broadly. The printing angle is an inference riding on top of it.
Which matters because the federal baseline never banned making a firearm for your own personal use. That's been legal for most of American history. The ATF rule was aimed at commerce, at companies selling nearly finished kits at scale. A frame printed from a spool in your own garage was always a somewhat different legal animal than a mail-order aluminum kit, and it remains a different animal after this ruling.
So the practical question, what changes for an ordinary maker on Monday morning? My honest read, having watched a few of these legal cycles from the press side, close to nothing immediately. The ruling changes the trajectory of an argument, not the contents of anyone's week.
Agreed. It's one district judge in one circuit, and an appeal is roughly as certain as gravity, with a decent chance the ruling gets stayed while the appeal grinds on, meaning the rule could snap back into force in the meantime. These fights flicker on and off for years, and even if it survives appeal, appellate courts love to narrow. The version of this ruling that's still standing in 2 years may cover a much smaller territory than the version in this week's headlines. Anyone making life decisions based on a week-old district court opinion is going to have a bad time.
There's also the layer most makers actually bump into, which isn't federal law at all. Printables and the other big model repositories ban firearm files as platform policy. No statute makes them do that, and no Texas judge changes it. State laws are a full patchwork on top. None of that moved an inch this week.
What I keep circling back to is the frame around all of it. This body of law was written assuming manufacturing happens in factories, places with addresses, licenses, loading docks, inspectors. That premise quietly broke the day. A receiver became a weekend project, and printing is a large part of what broke it. Courts are going to spend a decade relitigating that assumption, and this week was one round of a very long match.
So, landmark-sounding headline, real ruling underneath, and a strong recommendation to hold the sweeping conclusions until the appeals court and the actual text weigh in. Let's go somewhere cheerier. Cheap color. 3D printing industry ran a piece this week on a new Creality machine, the SparkX i7 Nano. Compact printer bundled with a little multi-material unit called the CFS Nano Kit, 4-color printing, and the number attached is $299. And notice I'm choosing my verbs carefully because everything I just said is what the announcement says. Announced is not the same as sitting on my desk.
With Creality, launch is a word with a lot of stretch in it. They have a long track record of announcing machines months before you can put one in a shopping cart, and the coverage here doesn't point to a shipping date. So the two questions I'd want answered before anyone gets excited: can you order this today? And is $299 the whole working system, printer plus color unit? Or is the bundle a promo that quietly evaporates once the launch buzz fades? Budget multicolor announcements have a well-documented habit of growing asterisks between the press release and the checkout page.
Even as pure announcement, though, the direction is the story. Ever since Bamboo dragged multicolor down to A1 mini prices, every competitor has had to follow. Color is turning into a checkbox feature the way auto bed leveling did. A few years from now, nobody will dare ship a beginner machine without it. And I'm mostly for it. Multicolor used to gate on either painting skills or a couple $1,000s of hardware, and now it's plausibly a starter printer feature. My whole hobby bench of miniatures says yes to this trend. The catch is that new buyers should walk in understanding what single nozzle color really costs in operation, because the sticker price is only Chapter 1.
Which deserves spelling out. These systems share one nozzle, so every color change means purging the old filament before the new one runs clean. The machine literally extrudes waste over and over, potentially hundreds of times across a single print. It's slow. It burns filaments you paid for, and no price tag on the printer changes that math.
I ran a 2-color terrain piece a while back, and I swear the purge pile weighed more than the model. Standing there holding a brick of rainbow spaghetti, doing the mental arithmetic on cost per kilo. Humbling.
And on a nano-sized bed, the purge tower is competing with your part for real estate the whole time. Physics doesn't get cheaper just because the printer did.
So, interesting if real, and a genuine signal about where the entry-level market is headed either way. When it ships and somebody independent puts a few spools through it, we'll revisit.
Now, my favorite story of the week, and the interesting word in it isn't V8, it's Tier 1. TCT had the piece. Bosch and Nikon SLM Solutions built an additively manufactured V8 engine block demonstrator, and the stated goal is establishing additive manufacturing inside automotive Tier 1 and Tier 2 supply chains.
Translate the tiers for the civilians in the audience.
Tier 1 suppliers sell directly to the car makers, and Bosch is about as Tier 1 gets. Tier 2 sells to Tier 1, and when companies at that level adopt a process, it stops being exotic and becomes something you put on a purchase order with delivery penalties and quality clauses attached. Back in my industry days, that transition from we printed a showpiece once to this is on the approved process list was the entire ball game. A demonstrator from Bosch means something a university showpiece never could.
Let me argue against your excitement for a second, though. We've been casting engine blocks for over a century, and it works brilliantly and costs almost nothing per unit. Why would anyone print one?
For a mass market car, you wouldn't. Casting wins on cost forever at volume. But an engine block is a brutal showcase part. Water jackets, oil galleries, thick sections next to thin ones, sealing faces that get machined afterward. If your process survives an engine block, it survives most of the catalog, and at low volumes, the equation flips. Performance cars, luxury runs, legacy parts where the casting tooling died decades ago. Printing skips tooling entirely, and it lets you route cooling channels through places no casting core could ever reach.
Worth flagging that the operative word is still demonstrator. They built one, and TCT's coverage doesn't get into whether it has run on a dyno or been through functional testing. So this is chapter 1 of a supply chain story, not the ending. Quick decoder ring while we're here, because this process shows up again later in the show. SLM, selective laser melting, is a flavor of laser powder bed fusion. A laser welds metal powder into fully dense material, one whisper-thin layer at a time. Slow, expensive, and capable of internal geometry that nothing else on Earth can make. That last part is the whole business case.
Meanwhile, the other factory floor item, the Defense Post reported that Stratasys picked up $7.8 million from America Makes to expand its additive capabilities for defense, specifically to scale production of end-use parts for military platforms. The defense additive spigot we watched open earlier this summer clearly hasn't closed.
What is $7.8 million buy in that world? Because it sounds enormous and tiny at the same time.
Tiny for building factories, decent for qualification work. America Makes projects are usually cost shared, and the real deliverable tends to be data, proving a printed ductor bracket behaves identically coming off machine 40 as it did off machine 1 across operators and powder lots and months. That repeatability evidence is what lets a part onto an aircraft. I'll note the announcement is thin. Scale production with no volumes, no part families, no platforms named. Typical grant stage vagueness. Their phrasing, not a measured result.
Sustainment is the quiet giant here anyway, right? The headline-grabbing version of defense printing is titanium flight hardware. But the moneymaker is the unglamorous plastic bracket for a 40-year-old aircraft that no supplier has manufactured since the 80s. Printing on demand beats warehousing parts for decades, or paying to restart a dead production line.
And that is precisely where Stratasys lives. Big FDM machines, flame retardant, aerospace thermoplastics, ducting and cabin and bracket work. Deeply unsexy and probably the most defensible business case in all of defense additive.
Now the story that made me sit up straight this week. Tom's Hardware covered a Thysis, an Indian startup all of 2 years old, test firing what they describe as a fully 3D printed reusable cryogenic rocket engine built with SLM, same process family as that V8 block, aimed at small satellite launch vehicles.
Cryogenic is the part that impresses me. That means propellants stored at hundreds of degrees below zero, so the hardware gets hammered by extreme cold on one side and combustion heat on the other, sometimes millimeters apart. A tiny team even attempting that is only possible because printing collapsed the supply chain. No forging house, no casting vendor, no 6-month lead times. Powder, a machine, and fast iteration. But two phrases in that description need daylight. Fully 3D printed, does that mean the combustion chamber and injector, which is impressive and increasingly standard practice, or every valve and every piece of turbo machinery, which would be extraordinary and which I'd want to see documented? And reusable, you demonstrate reusability by firing, inspecting, and firing again repeatedly. A single static fire demonstrates that it fired once.
Fair, though I'll push on the framing. Even if it's just the chamber and injector, that's the modern playbook. A printed injector replaces what used to be hundreds of individually drilled and brazed pieces with one consolidated part. And it's the approach that got small commercial launch engines flying in the first place. What's new is, who can run that playbook? A startup that didn't exist 3 years ago in a country building out its private space sector fast. The claim inflation bugs you. The barrier collapse is still the real story.
No argument on the barrier collapse. Printing turned rocket engine development from a national program into a funding round. And that's one of the best things additive has ever done. I just want the resume to match the test log before we crown anybody. Right now, we have one General Tech Outlets report and a startup's own vocabulary.
The tell will be the second firing. Startups announced the first one loudly. The fifth firing of the same hardware, mentioned quietly in an engineering update. That's when the word reusable gets earned.
And now IBM has invented, checks notes, 2 additional dimensions. Fabulou reported that IBM was granted a patent for something it calls 5D printing, a robotic arm that uses sensors to compensate in real time when the workpiece moves during fabrication, with the extra motion counted apparently as extra dimensions.
Before you deploy this SI, the underlying capability sounds legitimately useful. Printing onto a workpiece that isn't perfectly fixtured, repair jobs, adding features to existing parts, hardware that shifts as it heats and expands mid-build. Those are real problems that real money gets spent on.
The capability is real, and it is not new. Robotic directed energy deposition rigs, the big format polymer extrusion arms. This industry has been closing sensor feedback loops around moving tool heads for years. What IBM patented per Fabulou is a particular flavor of that. What IBM branded is my problem. Extra motion axes are not extra dimensions of space. They're axes. By that arithmetic, the 6-axis arm I worked alongside back in industry was doing 6D printing, and frankly, I want back pay.
Somebody will announce 7D by Christmas. It's an arms race now. The patent angle is what I'd keep half an eye on, though. If the claims are written broadly around real-time path compensation in general, that's a licensing shadow hanging over companies already shipping this capability under less ridiculous names.
Maybe, but IBM farms patents at industrial scale, thousands a year, most of which never touch a product until this shows up in a machine or a courtroom. It's a filing with a silly name. And if it ever does show up in a courtroom, prior art on robotic deposition with sensor feedback is not exactly thin on the ground. The people who've been doing this for a decade have the papers and the shipped hardware to prove it.
So the verdict for the file. Technology real. Precedent already out there working. Name pure marketing helium.
Real capability, deeply unserious label. If a vendor ever quotes you a dimension count above 3, ask them to point at the 4th one and enjoy the silence.
One thing to try this week, straight out of the cheap color conversation. Before you spend a dime on any 4-color system, Crealities, Bamboos, anyone's, take a model you'd honestly print, set it up in your slicer's multi-material mode, and just read the estimates. Waste grams and total time, right there on screen. For free, no hardware required. It's the closest thing to a test drive the purge problem allows.
And poke at the flushing volumes while you're in there. The setting that decides how much filament gets burned per color change. Dark to light transitions are the expensive ones. Red into white will eat you alive. If the slicer says your 2-hour print became 6 hours and 80 grams of purge, that's not a bug. That's the product. Better to meet it in software than on your credit card statement.
Do the math before the machine does it for you. That's the show. Go print something this week. Preferably not onto a surveillance camera, and we'll talk next week.